Good afternoon. This is Mike Brakey, and this is Black Swan Climate Theory, the NOAA cover up, part 2 of 5. In part 1, I gave you an introduction, a little bit of my background. In part 2 here, I'm going to give you a quick overview of the importance of heating degree days in Maine and throughout the country. If you want to see more detail, I would recommend going to the presentation I did on the New Gloucester Economic Development website. With that, we'll get underway. In Maine, there's essentially 32 weather zones for this great expanse of Maine. And based on recent personal research, I have now first-hand evidence of Maine climate data as being manipulated and faked to fit climate change fictions. I was recently asked to update the New Gloucester Economic Development Committee about successful energy R&D we've been doing on a lake lodge for the last 6 years. So I have been following heating degree data very closely and archiving some of it. To the right is the image of the television presentation. There is the link if any of you want to see it. All you have to do is once you go on board is click video on demand. Anyone can access the presentation. If you want to go directly to the website with the presentation, that's the link to it. And the PowerPoint presentation is about 59 minutes long. There was a 15-minute question and answer period afterwards. To keep that presentation under an hour, I really didn't get into the heating degree day information that much, but we'll take this opportunity to get into it more heavily here. That happens to be the image of the presentation I was doing, which was energy efficiency ideas for your home and business. The key thing, and I'm going to go through this fairly quickly, is there's two variables I found I needed in my research on determining a building energy footprint. And one is monthly heating and cooling degree days. And essentially, just imagine that you have a thermometer that's going to be set year round at 65 degrees. Assume your business or home thermostat is set at that level. Then if the average outside temperatures was 10 degrees, you can calculate your heating degree days to be 65 minus 10 is 55 heating degree days. If your summer months, and let's say you average 80 degrees for the day, then same calculations would yield about a 15% cooling degree day. And if you combine the effects of both these over an annual basis, you can actually work numbers backwards to get an estimate of what the average temperature was in that particular location for the entire year. Maine has published some information, Maine Encyclopedia, that shows 49 locations and used 30-year averages from 1971 to 2000. I happen to be looking at this point in time for the Lewiston Auburn, since it's right next to New Gloucester, and that's where we see the heating degree days, the cooling degree days, and I can use that information and get an approximate value of what the average temperature was on average over those 30 years. I might add this website has not been updated in the last 15 years, and based on what I've seen recently, I would highly recommend that they update that information. So here we are. We have these 32 zones. Why are they important? Well, if you happen to be down in what I call the sweet spot, you're going to have less heating demands than if you were up in the Allagash towards Fort Kent or Presque Isle and so forth. So it's important to know what zone you're in. New Gloucester happens to be in one of the warmest zones, zone 19 here. 18 would be slightly warmer and 20 would be slightly cooler. The importance of this is if we use the 30-year average on degree days, is if we said New Gloucester was our baseline, zone 19, and we could move that building around, and if utility costs were identical everywhere else, we could do a straight calculation to figure out how much more or less we would have to pay for electricity solely based on heating and cooling degree days. Now, I've made a point, especially in recent years, to seek raw, unfiltered data, and there's a lot of excellent sites. Here's one, Weather Data Depot, um, that you can pull information off of. Now that I have that information, the next thing I want to look at is total overall energy consumption at the facility. And if I can capture all the energy bills to know what has gone into this house for refrigeration, for heating, for running lights, electric stoves, televisions, and so forth, that all ultimately ends up becoming waste resident heat that can be captured. And so with that, I could see if there's any relationship, and you would think there would be, that as temperatures get colder, your energy bills would go up. Um, if there is a correlation, then we should be able to find it with some statistical curves, the same ones I used 20, 30 years ago in my heat exchanger research. And essentially, that's essentially what I did here. I took the heating degree days, I looked at total energy consumption, everything converted to BTUs. From that, I have a total BTUs. Is it good or bad? Well, you really don't know unless you have some tables to differentiate based on size. And there's an excellent table from the government that essentially looks at you take millions of BTUs consumed, divide by the heating degree days for the facility, and the total living space square footage. When you use these are non-inflationary numbers, and from that you can determine a hardcore number, and from that number you can determine how efficient your home is compared to others. For instance, our number here was 10.99. It says if you're between 10 and 15, that 55% of the homes are more efficient than you, and 45% may be less efficient than you. So that gives us some hardcore numbers. Um, the only other thing that went on here is eventually we're converting everything over to electricity, so I needed to see how much electricity would be used if we converted everything over. That's unimportant really for this presentation. It was more for the television one. Once I got that information, I could see if there was any correlation between heating degree days and energy expended, and you would think there would be some. The key thing is if you can find a statistical equation that's correlation greater than 70%, it can give you guidance. It can tell you what the implications are, what its energy footprint is as temperatures vary. As we looked at these four equations, when I entered my data, two of them, very little, if any, correlation. It'd be hard to pull anything. There was one that had 76%, but another that was 93.5% correlation. So there was a very close relationship between energy consumption and heating degree days. The only reason I mention this again is because you need good, accurate heating degree days to prove if there's any correlation. You can't use filtered information that may be unreliable. The fact that I know this data was reliable, it helps in a way, the 93.5% verification. So I have a relationship, and again, for this presentation, I'm not going to get into too much detail here, except that the data proved to us what we pretty much suspected. We had an energy hog, And we're going to be expanding at 50%, which means an energy hog would consume even more energy. The television presentation shows all the things we did to eventually reduce energy consumption tenfold. We essentially took a 4,900 square foot home and saved enough energy, it made it seem like a 500 square foot home compared to the average energy losses. And so this was our new energy footprint. Again, using the relationship of BTUs of heat consumed versus, and again, it's very important, you need to have accurate heating degree days to accurately predict what's going on. So now we have a dilemma here, and I'll just click this.
I want to kind of backtrack a little bit. Remember, we talked originally about there are three basic scenarios that we could run into.
Right.
Closed loop, standing column, and open to recycle. Okay? And
We're going to be looking
pretty
at
much
a
focusing right
geothermal
now on
system
standing
here.
column, where we're returning all of the, or
And
the water back into the system.
when you put in a heating system, you've got to have accurate information. You don't want to potentially undersize, and after the well's been dug, after the ventilation ductwork has been put in and whatnot, you determine you need a much larger system. So we're very carefully and accurately trying to figure out what will we need for the next 30 to 50 years. The original concern was 10 to 14 tons of heating and cooling for the lodge, but due to all the energy improvements we did, and based on results from blower and the door tests, um, we now had accomplished many of the energy efficiency things needed. And at that juncture, we knew we had a tight home. Instead of 8.4 turnovers a day, we're 5.2, but it's a large home and the air is going to be continuously circulated. The question was, in southern Maine, in zone 18 and 19, they typically size worst case of -1 degree Fahrenheit for continuous heat load, severe heat load. If that's the case, all I need is about 4 tons of HVAC we've calculated. But if we thought the weather and temperature patterns were indicating we might get severe cases of -20 or -30, it would require a 6-ton HVAC system. So here's the dilemma. Which do I select? And this is where, again, the heating degree data, historical heating degree data, is going to be so important. And that's what we'll get into in parts 3 of 5. Thank you.